Cool, doors are being closed. Hello, folks. Good afternoon. Welcome back from lunch. I'm Justin, one of the co-founder of Lattice. Some people know Lattice as the company that started Mud, and then later the company that launched Redstone Chain. In other words, what we've been doing is building infrastructure for autonomous worlds. But as you might have seen from Alvarius' opening talk this morning, we actually started off by building an on-chain game ourselves about like 2 years ago. I was personally fascinated by the idea of building multiplayer games on the world computer, following the footsteps of Gupsheep and Dark Forest. We're super interested in the idea of Ethereum as a computer that knows single-party controls, that allows immutable physics and rules, that enable massive, valuable player-based economy, and has an open code-based and API by default for anyone to extend. And while these properties are pretty damn magical, the computer also had some significant downsides. First, it had no development framework. There's no Ruby on Rails, no Unity, no Unreal Engine. And so that's why we basically built Mud from the ground up to make it possible to develop on-chain games in the first place without spending 2 years like Dark Forest to get like a few features up. We were hoping to see the next 10 Dark Forest emerge from this work, and the amount of projects that we're demoing this morning is a testament to the success of these theses. So second, the issue with the world computer is it costs a ton of money to run. Dark Forest was first running on Robston testnet, and then they broke the testnet, and then they moved to Gnosis Chain, formerly called XDAI, because running on mainnet was not possible, and this was before L2s. And so running any decently complex game would cost you hundreds of dollars every day, even with blobs, basically. So the second large infrastructure project we worked on is building Redstone and the underlying ALDA and OP Plasma protocol with the OP Stack team in order to reduce cost dramatically without impacting the guarantee of the world computer too significantly. And so with these two upgrades, we saw the design space open up like massively. Many games are being worked on, as you have seen in demos this morning. This is a snapshot of the logos of the people that presented so far. But the computer still lacks some pretty significant capabilities. And we've been kind of thinking, what further improvements can we make to the computer to benefit all of these existing projects and further open up the design space? And I mean, we have some leads on what needs to be fixed next. So first, the computer is still slow as hell. Actions are being confirmed after 2+ second delays on most L2s and half a second on the lowest latency ones. Like this is about as close as you can get. And even then with all the other kinds of overhead from tools, usually reach like 1.5 seconds to 2 seconds. The second biggest issue is creating an account is also like extremely complicated. You thought going to the game store and buying World of Warcraft and putting your CD key in was hard. We found something harder. So after you create an account on the world computer, you have to like add money to it, and because otherwise you can't make further actions. It's a whole issue, and there's a bunch of people working on that. We're not saying we're the only one doing this, but it has been difficult to find integrated solutions that don't bring other kinds of problem when you start adding this stuff up. And so earlier today, you know already if you're too online because we tweeted about it. If you don't know about it, I'm proud of you guys for not spending all of your time on Twitter. We announced Quarry, which is an upgrade to the computer that tackled both of these issues. So the biggest thing from Quarry is we basically decreased the latency 99%, from the node to common 2-second block time to as low as 7 milliseconds. We also made it possible to have one-click passkey-enabled account creation with sponsored gas. So behind this mumbo-jumbo, what this means is your players can just start playing immediately and then onboard progressively. And in order to show you, because we hate the meme of like just build a bunch of infrastructure and hope people are going to be able to make sense of what you've put together, we actually spent a lot of time building a bunch of demos. So the first one is Doom. We'll see if that plays. There we go. So this is Doom, specifically Chocolate Doom, a fork of Chocolate Doom. And it's running on Quarry. So this runs at about like 35 FPS because of the netcode of Doom. Transactions are sent to Quarry, confirmed in about like 7 to 15 milliseconds, come back and reflects the state update on each client. So this is running in real time. There are no tricks. There are no like optimistic updates or like a lot of client code to make this work. This is basically just Doom with like a little bit of Mud state synchronization on top. And some interesting things to point here is every second, each client is sending 35 transactions, so inputs and state update to the chain, from which the other clients receive the information to synchronize what's shown on the clients. And because of the way Doom was written, which is very poorly, I mean, we forgive them. They're the first kind of like multiplayer first-person shooter. It's before any modern netcode implementation, so there's no predictive netcode, there's no rollback, so any little amount of latency gets reflected immediately because the whole game freezes. So as we've been optimizing Quarry over the last 2 months, Doom became kind of our benchmark. There was a notorious problem where every 2 seconds there would be a little blip that we didn't catch when we were working on Quarry, but that was like pretty significant when playing Doom. So yeah, it has been great to kind of use that as a target for, hey, if we can run Doom on Quarry, then we can run anything we want. The second demo I have, if it plays, yes, is Move the Fly. So Move the Fly, oh no, don't spoil it. Okay. Move the Fly is a game where you can either move a fly or you can move a frog. Frogs eat flies. Flies don't eat anything. They just get eaten. And you can start playing Move the Fly by putting out your phone, either doing Face ID if you're on an iPhone or the Android WebAuthn protocol, and you can just like get into the game immediately with a smart account wallet and play with the same kind of latency as Doom. So this same thing, this doesn't have any optimistic update. This basically plays like a Web2 IO game, you know? And in order to build this, we pulled out the normal mud template and we added like 2-3 lines of code to connect it to Quarry. And one last demo I want to show you folks is this, which is basically Fortnite. So we took the code base from OPCraft, we added guns and walls. Alvarez, who is the worst person at making names at the company, called it Mineshoot. We all hate it. It's such a stupid fucking name, but it's called Mineshoot. And there's a lot of interesting things in this game. So first, all the physics is on chain, so jumps, movement, etc. Raycasting as well, so you can't just like declare, hey, I'm hitting that player. There's actually like a full raycast happening on it. And all of this just runs same thing without tricks. When we built OPCraft, you actually had a lot of tricks to make it feel good. This doesn't have any trick at all. We just like removed a ton of code. So these are the 3 demos we have. You'll be able to try them at the gaming corner at 3 p.m. I think later today. Now I want to talk a little bit about like how we made this. So common across the 3 projects is the need for low latency without sacrificing onboarding. So we'll talk about how that works. So this is a traditional block building algorithm. So transactions come into the mempool, they get ordered right before the payload gets built by the consensus node, and then people get their confirmation if the transaction landed in the blocks after about 2 seconds. The way Quarry works is the block building algorithm does not span 2 seconds. It operates on much smaller micro batches. And so you stream the block as it's being created. We're not creating the blocks every 17 milliseconds. That would be really silly because it would overwhelm different kind of infrastructure like block explorers, wallets, etc. You would also spend most of your time computing Merkle roots, which is the very expensive action when putting together a block. So the blocks get streamed to you as you play. And because we don't actually need things like the block hash in order to reflect a state update in the game, you don't actually need to wait for the full block to be built to be able to see what happened. And this does not like introduce any additional kind of like security assumptions in a rollup. The way rollups work with centralized sequencer is basically there's a window of time of about 20 minutes where the sequencer has sole authority over how the blocks get built. So this does not add essentially like any guarantees at all, any assumption at all to the whole system. So the hot path of Quarry, which is users sending a transaction, adding it to the bending block, and getting a stream update, happens in about 7 milliseconds. So we're able to do this by essentially rebuilding the whole stack. So we rebuilt the load balancer, we built a custom block builder on top of the Reth modular architecture from the Reth team, and we also rebuilt our indexer. So everything is very tightly optimized. We also spend a lot of time on the networking. And you can see that as these pending transactions get streamed back to the users, an actual block is being built and then sent back to other kinds of infrastructure, whether they're a block explorer or other periphery. The other interesting thing is most tooling out there for like stuff like ERC-437 and onboarding actually creates a lot of latency because it's just another part of the hot path. If you want to send a 437 user operation and you have to go through a bundler, even if you have fast block time, you end up spending like 1 to 1.5 seconds doing that. So we built a bundler and a paymaster inside Quarry itself. So the 7 millisecond loop remains the same, even if you use these kind of onboarding features. So it's pretty neat because you can have something like Move the Fly where you basically scan your face. It's a bit dystopian, but you scan your face, you become a fly, and you can move the fly around and do all of that stuff by using like everything you would expect if you're a developer. Like, I want to have my users like log in with an email, and I want to be able to like sponsor their gas and all that. And you can do all of that with Quarry without increasing additional latency. So the way this works from a networking perspective is we have built kind of like a series of edge regions on bare metal with servers all around the world, where we have copies of the state that get synchronized with a central sequencer and copies of WireSo or block builder. So currently the thing that's live is a single WireSo per chain. So there's a single place in the world where things get built. Over 2025, we want to build a system. We've already started working on it, but it's not ready yet, where the state of a mud world can be partitioned into different geographical location, such that you can have different matches, as an example of SkyStrife, or of different regions of biomes, where the computer doing the ordering can be in Asia, North America, etc. Because even if we have 7 millisecond latency, you still have to pay the cost of light. Sadly, we have not worked on that yet. We'll probably do that later. So yeah, we hope that this both benefit existing mud games and significantly expand the design space of on-chain games and worlds. It's basically plug and play. You just have to add 5 lines of code to your system. So I had some biome shell, but I will skip it. Sorry, guys. So that's it from me today. To learn more, you can scan this QR code or go to this link, lattice.xyz/quarry. It's available on DevNet, basically starting now. You can already build on it. And at 3:30 p.m. at the Gaming Corner, we'll have a Doom tournament. So thank you.
All right, we have 3 minutes for questions, apparently, so stay here.
Oh, man, okay, right.
If you
I'm
have
also
a question,
the MC, so I can't MC myself, so I brought flow.
if you have a question, you can either scan this QR code, or if people have a question also, they can just raise their hand, then I can run and give the mic.
Yo, if I'm doing local development, can I run Quarry, like this whole system locally, or do I have to do it on DevNet at all times?
Yeah, currently, yes. So you can put Anvil in Automine, but actually, funny enough, Anvil Automine is slower than Quarry. So yes, we don't have great local development environment yet, but we'll probably work on this next, because this is a distributed system. It's kind of a pain to run yourself.
All right, we have another question here from somebody in the audience. What about Doom logic? Is it being validated on mod?
Great question. So out of the 3 demos you've seen, the Doom demo only uses Quarry for event relaying. So what we do is we take keystrokes from Doom, which is how the P2P network, the P2P protocol of Doom works, and we relay it through a single mud table. We actually attempted to rebuild all of Doom in mud, but there were so many like weird fucking problems because John Carmack is insane that we kind of like gave up, and that's what we built Mineshoot actually. So Mineshoot runs fully inside mud. It's not just using mud for event kind of like coordination, but for the Doom demo specifically, we only use it for sending events around, mostly as a benchmark for latency.
Next question is, what is WireSo?
WireSo is a block builder. The reason it's called WireSo is because we have our internal theme for names is blue collar workers. So we have Quarry, WireSo, Redstone, Rhodolite. So it's either stones, stuff to cut stones with, or things related to stones. Next question, please.
People in the audience really want to know how your last name is pronounced.
My last name is, it's kind of funny because it says, is it pronounced Glibbert or Glibbert? It's pronounced Glibbert, so you were right.
Nice. Can you expand more on the features around gas sponsorship?
Yeah, so the way it works is we have a paymaster that's part of Quarry that like gets evaluated within the sequencer. And so this paymaster exposes rules you can tap into as a game developer, saying like either like users can get their first 20 actions sponsored by the game developer or under these certain conditions. So you kind of have like a whole system you can tap into to have flexible sponsoring.
All right, I don't see any new questions on here. If you have another question, you can also raise your hand real quick, and I can hand you the mic. All the way back, okay. Somebody else is running.
Hello. Have you tested how many players can it support on this update?
Yeah, so the bottleneck currently, I mean, it would always be the bottleneck, is the size of the blocks. So Quarry doesn't really add, like, the Quarry doesn't really have currently, doesn't get bottlenecked by stuff like CPU and RAM if you use good enough machines. The issue becomes how big your blocks are. So as an example, if you have transactions that consumes a tiny amount of gas, you can actually put a lot of players. If you have actions that use a ton of gas, you end up being bottlenecked by block size. So it really depends on what you're doing. But I mean, I'd say you can probably have like, depending on what you do, you can probably get like 200 concurrent players per chain, probably. Like doing actions all at the same time, all the time in a hot loop.
That's pretty cool.
But for Doom specifically, it's not the case. Like Doom is just a beast of a demo, and you can't get to 200 players.
All right, another question that we have is, can we use non-EVM networks underneath?
No. Because we have not built that. Like this whole thing is deeply integrated in the way Ethereum works, all the way from the clients to the sponsorship to the block building, etc. So no.
Cool. All right. Somebody's asking, will we be able to use pods with Quarry?
Absolutely. So pods, which stands for provable object data, also known as frogs. All of your frogs are pods. Pods, all frogs are not pods, but all pods are, actually, some pods are frogs and some frogs are pods. It's not an exact mapping, but yes, you'll be able to bring pods on chain and settle them because pods can be verified in EVM.
All right, and I don't see any more questions here. We have 30 seconds if somebody wants to raise a super quick in-person question, but I think we're good. All right.
Thanks again.